Here's a system of equations containing fractions. And there are two ways to deal with this. One way would be to just deal with the fractions and multiply one of the equations through by something that will create opposite coefficients or the same coefficients, and you could add or subtract the equations. In this case, we could multiply the entire first equation by 2, and that would actually create the same coefficient of x, 2/5 x, or 2x over 5. It would actually create opposite coefficients of y. You'd get negative half y up top, and you'd have that 1/2 y on the bottom. Remember that y over 2 means 1/2 y. So that's one option, but for the sake of practicing, we are going to actually clear the fractions here. You could do it either way. You could do it the other way as well. But like I said, just for the sake of practicing clearing fractions, we're going to clear these fractions, because there will be situations where clearing fractions is the best option. So to clear the fractions in the top equation, we're going to multiply by the least common denominator of all the fractions you see there. We've got a 5 and a 4 in the denominator. So the least common denominator would be 20. So if I multiply that whole equation by 20, I have 4x minus 5y equals 20. The second equation has a least common denominator of 10, because a denominator of 5 and a denominator of 2, if we were trying to find a common denominator, we would use 10. And when I multiply through by 10, I get 4x, because 2/5 times 10 is 4, plus 5y equals 30. So you could see this system of equations sets up very nicely for elimination. All I have to do is add the two equations together, and that'll just eliminate the y's. So we get 8x equals 50. Divide both sides by 8. So x equals 6 and 1/4. Right, 50 over 8. 8 goes into 56 times with 2 left over, so 2/8 is 1/4. So x is 6 and 1/4. And if I substitute into, I'm going to actually substitute instead of an original equation, because I've got all those crazy fractions, I'm going to substitute into one of my reformed equations. 4 times 6 and 1/4, I'm going to write that as 25/4 minus 5y equals 20. And the reason I wrote it as 25/4 is because it's easier for me to multiply that way. Those 4's are going to cancel, so we have 25 minus 5y equals 20. Subtract 25 from both sides, and we get that negative 5y is negative 5, so y is 1. So 6 and 1/4, or 25/4 if you prefer, it doesn't matter to me. 1 is the ordered pair solution to this system.